Hello, I'm Eric Snodgrass, and thank you for watching this Thursday night, April 13th in-depth ag forecast brought to you by Nutrien Ag Solutions. Some satellite imagery today really just showed us exactly what this pattern is up to. There's a large ridge. This is what supported all of the warmth that is spreading through this part of the country. And south of it, tucked underneath it, there is this deep upper level trough. And it almost looks as though, if you just watch back all day long, it looks as though it's tropical in nature, but it is a cold core system. And out ahead of it, we've seen some very large thunderstorms like the ones that hit and just almost remained stationary yesterday over Fort Lauderdale. Those are the ones that produce in some locations up to 20 inches of snow, or 20 inches of rainfall, excuse me. That's usually a number you reserve for snow. I think that's why I slipped up there. But 20 inches of rainfall. There are some very large storms curling around this evening as well. But what we're going to be watching here is this next larger wave kind of eject out of Montana with the deeper wave to its south coming out of Colorado. And it is also interesting to see as the sun sets here, just the snowpack that is still throughout parts of the west. We're going to see, unfortunately, a colder, longer range forecast for the west. And then as we just let the sun progress across, it is neat to be able to see the contrast between the colder water here and the much warmer water in the Gulf Stream to the south. In fact, you can see a large eddy that spun up right there. Just neat to kind of see that. Looking back at the last 72 hours of total accumulated precipitation, let's start from west and go east. The system that is now moving through Montana spreading snow, much of this snow did come through parts of the Columbia Basin, the Willamette Valley. And there's some cold air that is still behind this. But then we turn our attention down here to the system that is moving in parts of the southeast. And again, it's come in like this, but it will be moving toward the mid-Atlantic in the next couple of days. We do expect quite a bit of heavy rainfall out of this. Just to take a look at some of those rainfall totals, notice through parts of Alabama and then getting into Mississippi, we're talking 5 to 6 plus inches of rainfall here. And of course, in Fort Lauderdale, we're off my color bar. Now you look at the last 7 days, and it's important to note that there are some places that have seen no rain in a while. And because of that and the heat that's come through, we've had these red flag warnings spurred on by strong southerly winds. And I was watching today here over the Midwest, and if you just wait till the afternoon, there was a couple of fires, of course, coming out of Kansas. There was some in Nebraska, and this large one here in Iowa, which was really quite fascinating to watch on satellite, just pushing its smoke into southern parts of Minnesota. Now, if we look at where the snow came through, let's actually see if we can get an update on this. I'm hoping that I've waited late enough in the evening here to get the newest updates. Good. There we go. Apologize, this is so late. I was in Wisconsin today for a meeting, and I got home a little bit later than anticipated, and then I got to coach a soccer game tonight, so I'm getting to you a little bit later than normal. But this is total snowfall we've seen in the last 72 hours. And in parts of Montana, we've picked up over a foot of snow. There's a widespread area in here of about 3 inches of snow that came out of this. And the wave that did it is this little guy right here. Let that reset. There you go. So I mentioned a few moments ago we have a couple of waves. Here is the northern one. Here's the broader trough to the south of it. And here's the cutoff low that is underneath this larger ridge. And those are the 3 parts to this pattern we're going to watch here in the near term. So what we're keeping an eye on is this. This is starting off Thursday evening. We're still watching the snow in Montana getting into Saskatchewan, the heavy rains and potentially stronger storms that move in the overnight hours into parts of South Carolina, eventually to North Carolina. So we're going to have a stormy, start to tomorrow here across parts of North Carolina. Now, that lead wave, let's come back to the northwest here, shot off, and the deeper wave to its south is now going to follow this elongated pressure trough. It's just an area of low pressure. There's a front in there. And what we're going to watch here as we go through the day on Friday is snow spreading out of parts of Colorado into Wyoming and Nebraska. Some cooler rain out ahead of this. And then we're going to be watching very carefully for the risk of strong to severe storms right here on Friday evening. Let's go ahead and pull up the latest on that. Let's just go here to my website. I'm just going to go straight to the data we've got from the severe weather metrics, and there we go. So we can see that this is the risk tomorrow on Friday, or if you're watching on Friday, today, right in through this area. And then as we work our way into Saturday, we're going to see this elongate and kind of move from parts of Louisiana into southern Illinois. So this will be where that front gets. So let's get back to there and see how it progresses. Here we go. So again, this is Friday night, and we're going to work our way into Saturday morning, Saturday midday, and Saturday evening. So that's when the main front starts to slice through. So we got the severe storm risk from this part of Texas, Louisiana, through Arkansas, Missouri, and then into southern Illinois. And what has been a bit disheartening to watch over the last few model runs is that they've continued to bring in enough cold air on the backside of this that we could be looking at some snowflakes falling in here. Now, as we talked about all week, predicting snow on April spring storm systems is very challenging. So we will continue to have to now cast our way through this as it sets up. But right now, I just want to talk with you about the snow. So you saw the NAM model. This is what the European model is predicting. And you see that it is also attempting to put down snow on the backside. What's interesting is all week long, the European avoided this. It put more of the snow much farther to the north, but it seems as though the GFS model had this closer to right sooner. So this is just a situation where the European model, we just jokingly say it caved to the GFS. So if I just take you out there a full week and just look at how much snow is expected, we're going to be adding some more potentially to Wisconsin, into Iowa, and into parts of Minnesota. And we'll be waiting here at the end of this week to see if the National Weather Service begins to issue winter storm watches for this area. All right. Now, there are more storm systems coming to the northwest. I'm going to come back to that in a second. But I do want to show you that when you compare the models, this is, again, the European, this is the GFS, we can see better alignment on where the snow is going to be. Again, European and GFS. Okay, we need to see how this looks by also looking out at our longer range models like the GFS against the European. And let's play it out and see it here. So we're playing through the day on Friday. There's Friday midday, Friday evening. And remember, it's on Friday evening into Saturday morning. We're going to watch for the severe storms here. And then as we play forward into Saturday, that's 7 a.m. Saturday Central Time, 1 o'clock, and this is in the evening. Now we see that main frontal boundary moving through Missouri, stretching down into eastern Texas, and spreading some heavy rain and some storms. Now what you're going to notice is going into the overnight hours, this is now early Sunday morning, that's when we see the potential for the snow to come around the backside. And this is where the models are currently putting it, and this is the most they've been in agreement all week long. So then the low curls up over the Great Lakes, and what we see here is that snow curling around the backside, the colder rain coming in with it, which of course is not good for a lot of the crop that was just planted in this area. And that low spins up and kind of stalls just a little bit over the Great Lakes. It'll spread its heaviest snow into Ontario. Here we are out to next Tuesday morning, and now we're still waiting for it to clear the eastern Great Lakes, getting into Ontario and eventually Quebec. Now, while all of that's happening, the next storm system comes into the Pacific Northwest. So now turn your attention back here, and I'm going to take you back to Monday morning. So here's Monday, 7 a.m., and we just see this next low curling into the Pacific Northwest, spreading some more snow into the northern California mountain ranges, into Oregon, the Blue Mountains, the northern Rockies here. And then that system is forecast next Tuesday and Wednesday to emerge into the plains. It's got a different trajectory on it. It seems to want to put more of its snow farther to the north, up into Canada, but we see this one curling up, and the European model was the most aggressive on flipping this back over to snow on the headwaters of the Mississippi River here, maybe a little bit into the Red River Valley of the North. So that was kind of the really disheartening runs we just saw here after breaking away and seeing some heat. And then we just noticed we still are on this pace for like one system per week moving through the Midwest, with a front stretching down into the south, being fed on a high pressure cell that just sits off the southeast. So we're going to have to watch out Friday, the 21st, for the risk of strong to severe storms once again. So the pattern is certainly kind of opened back up, and it's got itself moving again. So why don't we do a little model comparison on total precipitation. This is just 1 week's worth of precip from the European model, and here is the GFS. So European versus the GFS. If we compare the two models, we notice that the European, let's shrink that up, is the wetter model throughout a lot of the United States. This would be seen in this map, which compares these two models as the European model being wetter here and the GFS being wetter there. All right, so just take a good look at this map, just good to kind of compare and contrast the models. What is just interesting to see, let's go here, is that we notice some of these key areas that have been missed out on precipitation. For example, the southern plains remain drier. Most of California, Nevada, Arizona, New Mexico stays drier. And we do see that the models just lately tried to push the next round of precipitation much farther east into the upper Midwest rather than hitting most of North and South Dakota. A lot of this, just remember, is right now. So this is what's going on right now in parts of Montana. Okay, so thinking about all of this and where the precip is heading and where it's missed. As we talked about for the last few weeks, the setup is to make this map just have more amplified colors. This area going drier, we're wetter in these corridors. We're wetter in parts of the west. So what you're looking at here is the last 60 days of precipitation expressed as a percent of normal. And we do have places that are in the plains that have actually not measured precipitation in the last 60 days. And the extent of the drought in this area, as seen by the latest drought monitor, has expanded. We now have a much larger area in what we call D4, that is exceptional drought in Kansas and parts of western Oklahoma. It's amazing to think how sharp the change is, though, from here to here on who has precip and who does not. We've seen parts of the northern plains come out of drought. We've seen the drought continue to be reduced throughout parts of the west, but where it has just stayed anchored is right there in parts of Kansas. Now, these soil moisture maps, which again are modeled, this is from NASA. These are also experimental, so NASA is testing this process because we don't have ubiquitous soil moisture probes everywhere. So what we're going to do is we're going to look from 4 inches to 16 inches at relative soil moisture. And going into any season, we like these numbers between 40 and 70%. Those are target numbers. That's enough moisture to last a while, especially if you have good soil. Wetter than that, you're going to have flooding like we have along the lower Mississippi River Valley and the upper Mississippi River Valley. Some of the areas I'm concerned about, though, is this area right in through here. We will see more precip north, but remember why this is still dry is we're down there below the frost point, still in the soil for some of this area. And we're just continuing to see that area show up quite dry. This whole state of South Dakota has come up in its soil moisture as of late as the snow has melted. So where are we abundant with moisture? Everywhere kind of east of this line. We've just seen quite a bit. Now, there are some dire pockets, don't get me wrong, but I'm just kind of trying to divide up the country and to show you what I'm seeing in terms of the haves and have-nots on this soil moisture. So from here, I want to talk to you about what it would take to kind of get precip back into this section of the country, because we have just seen how extensive the drought is here. And we're in April, and we've got May, and as soon as we get through May, we're in summer, the summer pattern. And the summer pattern is driven by thunderstorms. Actually, most of May and April are as well for the southern plains. So this is what I did. I went into the winter wheat belt using this great tool from NOAA called Climate at a Glance. And I pulled out a precipitation time series for 1 month, the month of May, for the winter wheat belt from 1895 to present. And all I wanted to just help us understand here is what drives these very wet years. So we plucked them out, those from 1970 to present, the wettest of the years, and I've stitched together some maps for us. So a couple of things that we're going to be on the lookout for. It really helps if the MJO stays quite strongly in phases 7, 8, and even 1. It helps if there's a lot of sinking motion that happens over Indonesia, over Southeast Asia, near Australia. So we need to have rising motion here and sinking motion there in the atmosphere. Now, the other part of this is, if you do develop, let's go back to this, a lot of rising motion here, the air is exhausted aloft and it gets picked up by the subtropical jet, just like that. And if you can get the subtropical jet going, then what it tends to do, look at this, from Hawaii into the west coast, it then curls itself here, drawing better moisture with a trough over New Mexico, drawing better moisture from the Gulf of Mexico into the central and southern plains. So if you want me to tell you what you need to break this cycle of drought, if we're going to do that at the end of April and through the month of May, we've got to get the jet stream to crank in the subtropical portions right down here. It's got to move and make a hard turn. It helps if it's cold out west, unfortunately, but we got to anchor a trough somewhere in the Four Corners states. That's it. That's what we're looking out for. That is aided when you've got the MJO here, phase 7. That's what this area is. So let's go look. I noticed that through the next 5-6 days, we have a lot of suppression here and rising motion there. That's good. I love seeing that. But the problem is it's weak. And the MJO, which made a big bounce out here lately, is going to kind of, right now, likely not get high enough amplitude in phase 7 and 8 to really enhance the chances for rainfall. But the good news is it is on the correct side of the diagram. If it were over here, we'd be talking about even more suppression of this drought. And by the way, why has the 3-year-long drought been in place? Well, because of La Niña for so long, the MJO spent a lot of time in this area. And it's just these correlations that we continue to look at to try to understand this pattern. So now what I want to do is I want to look to see if, because the MJO is going to try to be here over the next, let's call it 5-6 days, does the jet stream ever respond? So as we play this out here toward the 23rd, 24th, 25th, we start to see some of the things we want to see. This. Look how strong those winds are there. There's some component of it here. What is missing? The models are not advertising a deep trough right here just yet. They're actually putting the trough, I know it's hard, it's not really well resolved here, but they're trying to keep it a bit farther off the northwest. What is unknown is if this Pacific jet extension actually happens. So there's still some pretty sizable uncertainty out just the next couple of weeks. And that's why when you look at the week 2 forecast, this is day 8 through 14, this is going to be the 20th through the 27th. We just don't have strong signals in terms of total precip. The models just went wetter down in eastern Texas through the south and southeast. But I'm not seeing yet the models respond. The European model is much different from the GFS, which is shown here. The GFS wants to target more moisture into Northern California, Oregon, Washington, into Montana, and then here. This whole region is looking wetter than normal in the GFS model. So this would actually tell me that there's better chances of having this trough that I want to sit and spin here to bring in that moisture, likely going to be spending more time here off the west coast. That's where it's been. And so I guess right now we're going to see more of a persistence in this pattern than we are going to be able to see a true pattern change. Because since March 1, the jet stream has come over this high over low block. And what we've had here is just a piece of it that just keeps dipping into west coast troughs with weaker southeast ridges, and the flows come across the middle. So we've been questioning all along, are we going to go back into something like that? And we look out there at day 10 and just play out there through the 25th, 26th, 27th, and we just keep seeing troughs reinvigorate here. They move closer to the coast, and we just see other troughs off the east coast. So in other words, what I'm telling you here is this pattern wants to keep building troughs in the west, just like we talked about on Monday night. And the other thing this does is this prevents any sort of large, long time period breaks of warmer weather. We're getting, in fits and spurts, but just not sustained warm weather. So let's talk about the temperatures now. When we look out here, I want to show you this animation from the European model, but I'll be honest, I just want to focus on one thing. It is this hard contour line I show you right here. What we're watching for is how far to the south that gets. So here we are getting into, we're going to look at the early morning time periods. This is now 7 a.m. on Sunday after that low spreads through and is possibly putting down some snow on the backside. Frost line right in through here. Let's go ahead to Monday morning, 7 a.m. Now we have the frost line, it's along I-80 as an example here. We then go into Tuesday morning as the low curls up farther to the east. And again, remember how I had some concern that we could get this maybe down to I-70, right in through this corridor? We still see it flirting with that on Tuesday. And then as we play forward, here's the quick rebound in temperatures that happens next Wednesday and Thursday. See that big warm up here, pushing the frost line way back up into Canada? But there's just a tendency, like look at there at Friday. Let's go there to Saturday morning, the 22nd. Another round of that colder air that's coming through. So this is going to be producing highly variable soil temperatures. When rain comes through timed with this cold weather, the problem is going to be that we're going to see, cold, wet conditions on this new, seed bed. And this is far less than ideal. And the warm-up we've had right now is something I've told you many times I missed forecasting. So to see this kind of going back over cold, this kind of returns to some of the original ideas we had. So let's just go ahead and take a look at what that temperature pattern looks like. 5-day sliding window of average temperatures. And here we go. Let's just play this out here and look at the time period of, let's park it right about here and just say this would be the 18th to the 23rd. The heat stays primarily in this corridor, colder west with those troughs. Can't seem to shake the cold north. And then we do see that as we get out there into that 4th week of April, that there could be another push of colder air that occupies more, of the country. So what's missing? Big, blocky ridges across the United States. We just don't have them. So we see this colder pattern lasting. The new European weeklies, which were just released today, show something like what you just saw lasting all the way into May. You need to know that we've got big question marks on this. because the moment this pattern decides to shift, it could be something with the MJO, it could be a little westerly wind burst from this developing El Nino, it could be something shifting in the North Pacific or over Greenland. Something's going to break at some point, and I think that this temperature forecast, while it's going to look like this for the next couple of weeks, I think it's going to really start to break away from this as we get into the month of May. So the big question will be, does spring, May precipitation come in like we hope? So right now the models are shutting things down here. So this corridor drier, this would be a major problem if it was in fact wet across the northern plains. We're still seeing things wet across the south. And to be honest, I'll just do what I kept doing for you. I think what we would need to do is encapsulate this whole area and say the risk inside of here is higher for being wetter. Also, if we keep persistent troughs in the west, we're just going to keep onshore flow going, which means Northern California into Oregon and Washington, and eventually to Montana will likely see wetter conditions as we stretch out over this 30-day time period of the 20th of April to the 20th of May. Until I have some bit of evidence to overturn this, this is what I've got, okay? Let's finish this up with a quick discussion of El Nino's arrival. This was just released today, so you can see on the 13th, published by the CPC, and they've now given the chance of an El Nino developing by June, July, August. It's at 75%, and we see it increasing even more as we go into the late fall and winter months. So there's just supporting evidence that this might not be a year where we whiff on the forecast for El Nino. So we need to remind ourselves what that means and understand that there's still some competition in the atmosphere here. Because as this all goes over warm for El Nino, and we get these westerly wind bursts occasionally in the trade winds, the momentum does tend to pick up in the Pacific jet going across the United States. Take note of how warm the water is here. That's going to help fuel moisture return and storms. Now, El Nino generally good for everywhere east of the Rocky Mountains for summer, and tends to be worse for the western United States. But this right here is still part of that negative PDO signal we've been talking about. And the top thing in the ocean temperatures that I'm going to be watching is how this changes, if this changes. Now let me give you the caveat here. If it doesn't, if we see this and it is like June 20th, then the chances of seeing a hot early summer in the west are way down. The chances of seeing a hot summer in the Midwestern United States and plains is increased. But it'll be a competition between the cooler water here and the warmer water emerging with El Nino. So let's go take a look at just kind of some model summaries here. The CFSV2, this is the Climate Forecasting System version 2 model. This is what they're currently forecasting out for May, June, July, August. In fact, let's take a closer look at June, July, August. We notice that limited chances of drier weather, most likely because of what it's forecasting for El Nino. July, August, September, it's actually got quite a large area that's wetter. And this is very much in line with the latest updates for June, July, August, and then July, August, September from the European model and from the from the NMME, of which the CFSV2 is a part of. So remember, this pattern, if it fully manifests itself as an El Nino-driven summer, weak southwestern monsoon, broader area of wetter conditions here, likely split flow across the west, and unfortunately that means the greatest axis of heat will go from Texas into the Pacific Northwest. All right, last thing I want to talk to you about is South America. No major changes in this forecast. Near normal rains in Mato Grosso, it's drier over the Amazon. Above normal rains in central Brazil, dry in Rio Grande do Sul and along the Paraná River Basin in Argentina, bordering on Uruguay. There's really not been much change except for it's just gotten wetter in this corridor. What I think this might do is it might just continue to push the safrinha corn crop out farther, maybe creating a little bit more of a gap in the crop calendar here, pushing it maybe 2.5, 3 weeks out. So we'll just watch that carefully. Okay, thank you for giving me a little extra time tonight. I look forward to giving you another forecast in the morning on Friday, and then we'll talk again next week. Thanks.